Service point versus service equipment. The service point is the point where the main electrical supply enters the building. The service equipment is the equipment that houses the meters, disconnects, and overcurrent protection devices, or OCTs. Multiple or single service. For large condominium complexes, it is common to have multiple services to ensure redundancy and better power distribution. For smaller complexes, a single service may suffice. Layout options include centralized metering, decentralized metering, and hybrid metering. Considering centralized metering, all meters and disconnects are located in a central location outside or inside the building. This simplifies maintenance and billing but requires longer feeder runs to each unit. Considering decentralized metering, each unit has its own meter and disconnect, typically located outside the unit or in a common area. This reduces feeder runs but requires more maintenance access. Considering hybrid metering, this is a combination of the above, with a central metering and distribution point for multiple units. Service equipment components include a main meter, individual unit meters, disconnects, OCTs, and a distribution panel. The main meter is typically a three-phase meter to measure the total electricity consumption of the complex. Individual unit meters are sub-meters for each unit to track individual electricity usage. Disconnects include main and individual unit disconnects that allow for quick isolation of the electrical system for maintenance or safety purposes. OCTs, or overcurrent protection devices, are circuit breakers or fuses to protect the system from overcurrent conditions. The distribution panel distributes power from the service equipment to the various units. Wire size and configuration. For typical 4,000 square foot units, a 200 amp service with 4 American wire gauge, or OC, feeders to each panel is recommended. The actual wire size and configuration will depend on the load calculations and applicable electrical codes. The general sequence of service equipment is as follows. Firstly, the service point, where the main supply enters the building. Secondly, the service equipment, including the main disconnect, main meter, and OCTs. Thirdly, the distribution panel, where power is distributed to unit panels. And fourthly, unit panels, where feeders connect unit panels to the distribution panel, providing power to individual units. Determining whether to use a single or multiple services depends on several factors, including the size of the condominium complex, the expected electrical load, and local utility requirements. Firstly, consider the size and number of units. For a complex with 20 large units, it might be more practical to have multiple services to distribute the load evenly and provide redundancy. Secondly, consider the total electrical load. Calculate the total load based on the square footage, appliances, and other electrical equipment in each unit. This will help determine the size and number of services needed. Thirdly, consider redundancy. Multiple services provide redundancy, ensuring that a failure in one service does not affect the entire complex. This can be particularly important for critical systems like emergency lighting and fire alarms. Fourthly, consider cost. Compare the cost of installing and maintaining a single large service versus multiple smaller services. This includes the cost of equipment, installation, and ongoing maintenance. Fifthly, consider local utility requirements. Check with the local utility company for any specific requirements or recommendations regarding the number and size of services. The types of service equipment available for multi-unit dwellings typically include metering cabinets, disconnect switches, overcurrent protection devices, distribution panels, and transformers. Metering cabinets are enclosures designed to house multiple meters for individual units. These cabinets can be configured for centralized or decentralized metering systems. Disconnect switches are used to isolate individual units or the entire complex from the electrical supply for maintenance or emergency purposes. Overcurrent protection devices, such as circuit breakers and fuses, protect the electrical system from overloads and short circuits. Distribution panels distribute power from the service equipment to the individual units or subpanels within each unit. Transformers may be required to step down the voltage from the utility supply to the appropriate level for the units, typically 120 volts or 240 volts. To determine where the service begins, understanding the definition of the service point and service equipment is crucial. The service point is the point where the utilities infrastructure connects to the building's electrical system. This is typically the property line or at a designated location specified by the utility company. The service equipment includes the main disconnect, meter, and overcurrent protection devices. The service begins at the service point. Everything from the service point to the main disconnect is considered part of the service entrance. The general sequence is service point from the utility, service entrance conductors, main disconnect or overcurrent protection, metering equipment, distribution panel. The service entrance conductors run from the service point to the main disconnect. The main disconnect is the first point where the building's electrical system can be isolated from the utility supply. The metering equipment measures the total electricity consumption of the building or individual units. The distribution panel distributes power to various branch circuits within the building. Regarding the number of wires running to each panel, a typical setup involves 4 wires, which includes 2 hot wires, a neutral wire, and a ground wire. This configuration is used for a 120 volts or 240 volt single-phase system. 2 hot wires carry the electrical current, the neutral wire provides a return path for the current, and the ground wire provides a safety path for fault currents. The specific wire gauge will depend on the load calculations and the distance from the distribution panel to the unit panels. Using appropriately sized conductors is essential to prevent voltage drop and ensure safe operation. When planning the service equipment layout for a condominium complex, consider the following best practices. Firstly, perform accurate load calculations. Calculate the total electrical load for each unit and the entire complex to determine the appropriate size and number of services. Secondly, comply with electrical codes. Ensure that the service equipment layout complies with all applicable local and national electrical codes, such as the National Electrical Code, or NEC. Thirdly, coordinate with the utility company. Work closely with the local utility company to determine the service point location, metering requirements, and any other specific requirements. Fourthly, provide adequate space. Ensure that there is sufficient space for the service equipment, including clearance for maintenance and future expansion. Fifthly, consider accessibility. Locate the service equipment in an accessible location for maintenance and inspection purposes. Sixthly, label all equipment clearly. Clearly label all service equipment, including meters, disconnects, and distribution panels to facilitate easy identification and maintenance. Seventhly, use high-quality equipment. Use high-quality service equipment that is designed for the specific application and environment. Eighthly, provide overcurrent protection. Install appropriate overcurrent protection devices to protect the electrical system from overloads and short circuits. Ninthly, use proper grounding. Ensure that the service equipment is properly grounded to provide a safe path for fault currents. Tenthly, document the layout. Create detailed drawings and documentation of the service equipment layout for future reference and maintenance. Remember to consult with a qualified electrical engineer or contractor to ensure that the service equipment layout is safe, efficient, and compliant with all applicable codes and regulations. They can provide valuable expertise and guidance throughout the planning and installation process. Remember to consider the long-term needs of the condominium complex, including potential future expansion or upgrades. Planning for future growth can help avoid costly modifications down the road. Also consider energy efficiency. Incorporate energy-efficient equipment and design practices to reduce energy consumption and lower operating costs for the condominium complex. This may include using energy-efficient transformers, lighting, and appliances. In summary, planning the service equipment layout for a condominium complex requires careful consideration of various factors, including the size of the complex, the expected electrical load, local utility requirements, and applicable electrical codes. By following best practices and working with qualified professionals, you can ensure that the service equipment layout is safe, efficient, and reliable.